For objective 3, we're looking at the quotient rule for square roots. So I know that I multiply these two fractions together. 3/5 times 3/5. 3 times 3 is 3 squared, or 9, over 5 times 5 is 5 squared, or 25. So I know that if I'm taking the square root of a fraction like 9/25, that it's the same thing as taking the square root of each part separately, because when I multiply fractions together, I multiply the tops and bottoms separately. So the square root of 9/25 is the square root of 9 over the square root of 25, or 3 over 5. Okay, so this example right here is just designed to show one example of this quotient rule for square roots. So the quotient rule for square roots says that if you have the square root of some number over the square root of another number, like in this example right here, that's the same thing as the square root of that fraction a over b. Okay, it's saying that we can take a square root that's written separately and write it as a single square root, or vice versa. A single square root can be written as two separate square roots in a fraction. Okay, we can see through this example, how it's working, and that it makes sense in terms of the way fractions already work. Okay, so that's the quotient rule for square roots. Now we're going to use this to simplify square roots, because square roots are not simplified if their radicand is a fraction. So we simplify by writing them as an expression whose radicand is not a fraction. Okay, so it's not okay to have a fraction inside of a square root like this. To fix that, we'll make two separate square roots, the square root of 16 and the square root of 81. And then we can take the square root of each of those. We have the square root of 4 over 9. Okay, those will be the two steps in simplifying this. I take the square root of both the top and the bottom. Now I'm not always going to be able to take the square root of both of them. So in this case right here, the square root of 7 over w squared, I'm going to separate into the square root of 7 over the square root of w squared. And we don't know the square root of 7, so we'll leave it as the square root of 7. The square root of w squared is w. This is one of the examples of why it's important to separate them into two square roots first, then evaluate the square root that we can. Okay, so that one's done. The same thing in this one. I don't know the square root of 12, so I'm going to separate this into the square root of 12 and the square root of 25. Then we'll keep going on this. Even though I don't know the square root of 12, I do know how to separate 12 into the square root of 4 and the square root of 3. And then for the 25, I already know the square root of 25 is 5, so let's continue. And then for the top and the 12, the square root of 4 is 2, square root of 3, over our 5. So we're using what we had learned in the last video about the separation of a square root into perfect square factors. So I had to do that with my 12, and then also separated my fraction into the two square roots. So let's try it again in the next one here. 32 can be separated into, let me look at this before I start talking about it. I just noticed that it's in two separate square roots already, so I could deal with them separately, or if I look at this as one big square root, I'm going to be able to reduce this. This is one reason for wanting to go backwards. We saw the two properties up here, one where you can pull together into one square root, and the other one where you can pull apart into two separate square roots. So in these three examples, we pulled apart. We pulled into different square roots. Part D right here is an example of why I might sometimes want to pull together into a single square root. Okay, it's useful to pull together into a single square root if that single fraction is going to be reducible. Because when I reduce, 32 divided by 8 is 4, x cubed over x is x squared. So when I reduce that fraction, I don't have a fraction anymore. I have a whole number right here. And I can take the square root of that whole thing. The square root of 4 is 2. The square root of x squared is x. Alright, so that was just my contrasting example of why I might sometimes want to pull it together as opposed to separating it. Okay. Notice that none of these fractions I had before could have been reduced. This is a case where I could, and so maybe it's better to pull it together first.